Hi, third graders. It's time to review our DMA 4 problems for our warm-up today. It's week 12, day 3. So we're on week 12 and day 3, just to make sure you're in the right place. It's December 2nd. So we're going to take a look at our first problem. It's a bar graph. And you'll notice that the scale is going to tell us the number of visitors that were at the park in a specific year. So we have the year 2010, 2011, and 2012. Always make sure to look at your title. So visitors to a park. So they want to know in this question how many people visited the park in 2010 and 2011. So, and, if you remember, helps us understand that we're combining these together. So usually when you see and it's talking about two pieces of information or two amounts, we're adding the bar of 35 visitors and the bar that says 40 visitors to find visitors for 2010 and 2011. Notice it doesn't ask us about 2012. We could, if they asked us the right question, include 2012, but again, we have to pay close attention to what the question is asking. So we're not going to use this information for our problem at this point. Now, if we were to take 2010, we said that that's 35 visitors in 2010, and in 2011, we have 40 visitors. And when we add those together, we would add, this is for 2011, and we would say 30 and 40 is going to make 70. And of course, 5 and 0 is going to make 75 at this point in time because we don't have any ones here to add. So there are 75 visitors for the total of 2010 and 2011. I'm just going to put VIS there for visitors as abbreviation. Now, I'm going to come back to this a little later because we're going to do a discussion question in your DMA folder or in your math folder today. So I'm going to come back to this. Our next set of problems, we're missing a factor here. And what that tells us is we're missing the number in each group for this factor. So I have 4 groups, but I don't know how many are in each group. But I know how many total objects I have because this tells me I have 4 total objects. So if I were to have 4 groups, and I'm just going to show these 4 groups, how many objects would I have to put in each group to come up with 4 total objects? Well, if you know that it's 1, I would put 1 in each one of these groups, and I would get 4 total. So that would be 1, 1, 1, and 1. And if I add 1 plus 1 plus 1 plus 1, I get my 4. Now, this is also a simple, or this is also considered division. Because with division, and we're going to start on division soon, 4 is our total. We're going to take those 4 total objects and put them into 4 groups. And we're going to come up with the number in each group. And I'll explain this more in detail when we get to division. But this is the beginning steps to division, is finding a missing factor. Here for number 2, we have 5 groups of blank equals 0. Well, if my total objects are 0, it doesn't matter how many groups I have. Whatever's in this group has to be 0 because when we add groups of 0, we get 0. And our missing factor here is the number of groups. But we know we have 7 in each group, and we have total objects of being 7. So we have one group of 7 is going to give me my 7 total objects. For the second one, we're going back to our understanding of the commutative property. So it says write a related multiplication sentence. So when we take our factors and we switch those factors, instead of having 3 groups of 7, we can say we have 7 groups of 3. And these are related because they both have the product of 21. All we're doing is switching the factors, which does change our picture because 7 groups of 3 is going to be different than 3 groups of 7. So we can show that these are equivalent to each other by using our understanding of repeated addition. So if I have 7 groups of 3, 1, 2, 3, 4, 5, 6, and 7, I know that 3 plus 3 is 6, plus 3 is 9, plus 3 is 12, plus 3 is 15, plus 3 is 18, plus 3 is 21. I know that 7 plus 7 is 14, plus another 7 is also 21. So I can show how they're related and they're equivalent to one another just by showing that they add up to the same sum when I use repeated addition. So I could write it also like this. 3 times 7 is the same as 7 times 3. Those are related to each other. Okay? And the last one is a word problem. It says there are 9 rows of 9 computers. How many computers are in the office altogether? Altogether helps us understand that we are either adding or subtracting, or multiplying, because we want a total. And when we are looking for a total number of objects, in this case computers, we know that we are going to either add or multiply. Well, this is telling us that they have 9 rows of 9 computers. So that means there's 9 rows with 9 computers in each row. So we have 9 groups of 9. Now, if we were to draw an array, we would have to draw 9 rows with 9 objects in each row. So on the other side, I can show that work, and I could draw my 9 rows. 2, 3, 4, 5, 6, 7, 8, 9, and I could put 9 objects in each row. And I could figure that out based on my drawing. And 1 more makes 9. Now, if you remember, we've been working on the distributive property, or we call it the break-apart strategy. We can use one of the factors, break it apart into 2 smaller parts, or addends, to find our total, which means that I could take the 9 and break it up as 4 and 5 rows, or 6 and 3 rows, or 7 and 2 rows, 8 and 1. It depends on how you feel most comfortable with breaking that up. So I'm breaking up 9 rows with 9 computers in each row, and I want to find the total computers altogether. So to help me with this, I'm going to use my distributive property, and I'm going to break this up as 5 rows of 9 and 4 rows of 9. So 5 rows of 9 and 4 rows of 9. And when I use this strategy to help me finding the total, I know that 5 times 9 is 45, and 9 times 4 is 9 plus 9 plus 9 plus 9, which is 36. And so if I add 40 and 30 is 70, and 5 and 6 is 11, together they are going to make 81. So 9 groups of 9 is going to be 81. Or you could think about 10 times 9. 10 times 9 is 1 more group of 9. So if 10 times 9 is 90, and I take away 9 away from that 90, that's also going to give me 81. So you could also think about using 10 times 9 as a strategy and thinking about, oh, I have an extra row of 9 here. 90 minus 9 is going to give me 81. So when we go to write this out, we would say the total number of computers is 81 because if I add
Ladies, when you are
9
leaving, please leave through the front door
groups
so I know that you are out of the building.
of
Thank you.
9, if I have 9 groups of 9 and I break up, I break it up, I break the array up as 5 rows of 9 and 4 rows of 9. So 45 plus 36 equals 81 computers. So we are taking our understanding from here and our array. We have an equation to show our work, and we've explained our work in an explanation to go with our work. So that's DMA for today. Oh, I was going to go back, sorry. Okay, so our discussion question for today, there is going to be a discussion question going back to my bar graph here. So the discussion question in your math folder for Wednesday is, how many people visited the park in 2010, 2011, and 2012? Now I want you to write an equation including all 3 years and how many people or visitors visited the park in all 3 years. And that's going to be your discussion question for your DMA today. So, interested to see how you give your answers, and we will see you on Thursday. Have a great Wednesday, guys.